We share entrepreneur stories regularly on the podcast, and today would be one of those. Today's guest has chosen to make the modern car smarter, and he'll share all about that with us. This is the Tech Your Business podcast where we break down technology, inform you about the latest in technology, and also do that to help your business learn more, earn more, and do more. My name is Peter, and today's guest is Boaz Mizrachi, all the way from Israel, and he's the founder of Tactile Mobility. So, welcome to the show, Boaz.
Thank you very much, Peter, and glad to be here.
Thank you. So, can you explain in simple terms, first of all, what your company Tactile Mobility does and why it's important for both drivers and vehicles?
Right. So, Tactile Mobility is a software company. We build software for two parts of the system. One is the ECU, engine control units. Those are the lean resources, computers that drives the vehicle today. And on the other side is on the cloud side. Okay, so the software is collecting information from existing hardware sensors in the vehicle, mostly in the chassis, like wheel speed, like accelerations, vibrations, etc. And then out of that, getting into insights, meaningful insights about how to drive the car in that situation. Those insights are then fed back into the system, normally using the network, like the CAN bus network there, and the customer functions in the vehicle can take use of those functions. For example, if I detect that my car is heavier or the road is more slippery, then I would like to keep a larger distance from the car in front of me, like when I'm using adaptive cruise control. Those insights, those that we call virtual sensors, okay, that are generated close to real time, are also propagated or transmitted up to the cloud, where close to real time or building maps of surfaces, maps of vehicle DNA or digital twin, as we call it, around the world that can be again used as the horizon, okay, in front of the car, like what the other cars have learned for you, okay, did you this favor, or like third party, like municipalities that would like to maintain roads, for example, like slippery conditions, etc.
So that's actually a very interesting idea, and considering the things this software, you say you're a software company, so consider the things it does for the drivers, for the cars. You can see how important this is, telling you how to drive safely, things like that. So let's go back a bit. What inspired you to start this business?
Right. So we started gradually, let's call it. So the first problem we wanted to solve back then, like even 15 years ago, was the energy problem. Is how to bring a car from point A to point B with minimal fuel.
Hmm.
And given that fuel back then was very high cost, no much of electric cars, especially for heavy trucks, etc., air pollution, etc. So everybody wanted to reduce the fuel cost. So in order to do that, the first thing we wanted to solve is how to measure the fuel consumption momentarily in the vehicle, right? Because it changes from a moment to moment. So um, we thought there are sensors there, hardware sensors for measuring fuel consumptions, but there aren't any
Oh.
because it's too cost, highly cost, etc. So it's only assumptions there or estimations. And those estimations were very far from the accurate value. So if I want to save 5 or 10% of fuel cost, okay, then I will need my sensor to work at least at 1% of accuracy or 2% of accuracy. But those estimators that currently were installed in the vehicle were like 30% off,
Wow.
20% off. So the first thing that Tactile Mobility was designing was a virtual sensor. Okay, it's software rather than hardware, so this is why it's a virtual and it's based on software. So it's a virtual sensor for fuel consumption. We call it fuelometer. Okay, what is my current consumption? So we managed to get it very accurate at the end of the day, like close to 1% or 2%, which was very nice. So once we had it, we could go to the next level of saving fuel and showing fuel savings. What happened is around 10 years ago, or less than that, the fuel prices dropped dramatically even. So nobody cared for saving fuel. However, on the other hand, there were other emerging fields like autonomous. Okay, everybody back then was talking about level 5, like driving without having steering wheel or anything.
Yeah.
And for that, you needed other virtual sensors or other sensors to feel the tactile sensings of the vehicle. So most of the sensors there were based on visual. Okay, so like I see, right? So there are like camera, like lidars, radars, even ultrasonic, okay, infrared. So each case uses the pixel to represent different things like depth, okay, or distance, or heat, or color, right? Now, these are all visual sensors, and they can give the perception, or maybe 90 or 95 of the percent of the perception that you need as a driver to drive the car. Okay, it's mostly visual. However, the missing 5%, or even if you say 1%, is still missing if you want to replace the driver or assist the driver. This is what we call tactile sensing. Okay,
Hmm.
so seeing the object in front of us is the most important thing. However, without knowing what is my current grip, okay, what is the friction of my tires with the surface, if you don't know that, then it's a very important missing information. Am I driving on black ice, okay, which I can't see but I feel it, or am I driving on a nice road? This will set the braking point in front of dangerous object that the camera will see. So a professional driver feels the road and feels the car, not just see the road in front. So what we wanted is that to take this feeling issue and bring it into something which is more software-wise, sensor-wise, and bring those insights, tactile insights, to the customer functions in the vehicle. So we're talking about grip estimation, we are talking about weight estimations, like feeling the weight of the car, talking about a tire status, okay, like what is my tire condition, do I need to replace my tires because of tire wear, okay, and other characteristics of the tire, what is the status of my suspension, brakes, etc., steering, so all the chassis components that are very important to feel them, okay, and to provide it to the functions of the vehicle.
Interesting. So I think I now get where the name came from, tactile mobility, because like you said, the visual sensors are
Like feeling,
95%.
yes,
Yeah. So you have
yeah,
that 5%.
even if you look at the icons that we are using here, okay, my shirt here,
Yeah.
like braille, okay, it's a braille sign. So because
Oh.
we always look at ourselves like the blind people who are sitting next to the driver, and we are so expert with feeling the road, okay, because we don't
Hmm.
see it, so we provide it to the driver. So that's what we do. It's like a braille readings of the surface.
That's interesting. Okay, so building this business over the past few years, what were the biggest technological challenges you faced over time trying to make this work?
Okay, so this is the first time in this podcast that we'll mention the term machine learning, okay, and AI, and
Yeah.
that everybody is talking about it. So in the next few minutes, we'll talk about it a little bit. So if you want to provide meaningful insights, okay, using current existing hardware sensors, you don't want to increase the cost of the car, right? And you need to, let's call it, dive into the signals, dive into the data of those sensors in order to derive something meaningful. Okay, that will be in order to do that, and this is what we call machine learning, okay, or AI, or there are different terms to state it. So in the real world, what we need to do machine learning, I mean, the major challenge here is to get the data, to analyze it, to test it, etc., etc. And this is one of the major challenges. So if you have missing coefficients in the vehicle, okay, if you want to have like some equation for energy or equation for forces, right?
Mhm.
According to that, you can derive what are my forces that I applied on my tires now, or what is my weight, my load, my current load on the tire. So there are tons of coefficients. Those coefficients change from time to time, okay? Like wind drag. If I will open my windows, my wind drag will change. If I put
Yeah.
my bicycles on top, it will change. So I need to calculate it every time, and it's very difficult. And the way that we are mitigating it is by machine learning. So let the machine, okay, learn during real time while we are driving the car. What are my changing coefficients of my tires, my body, my chassis, etc., in order to solve those equations? Now, the challenge for machine learning is that you need, if you have a large data space, okay, a search space, so because there are tons of different of configurations of the vehicle, of conditions of the tires, conditions of the roads, climate conditions, whatever, they are all changing. So if I want my machine to learn, okay, I need tons of data, diversified data. And this is the major, one of the major problems. Second major problem, if let's say I get this data, okay, diversified one, how do I annotate it? How do I know what was the ground truth while, okay, so I need to train my system for that. And the next part of that was the accuracy, okay? So the accuracy, if you can think of that, normally people do with machine learning, maybe 90% accuracy, 95, but with a car, if you have even 1% chance of being wrong with some calculations, then it's fatal, okay, maybe fatal or dangerous. So the success rate of your, or confusion rate of your machine learning should be less than 1%. Okay, how do we achieve it? And then on top of everything, you don't have, the biggest computation power in the vehicle. Those ECU are talking about the traditional one, and even the one that will be in the plain vanilla cars in the next 10 years are very lean resources. I mean, these
Yeah.
are like the computers you might have, I don't know, in a very low cost computation segment. So it doesn't change. So how do I take this complex machine learning and put it into low memory and low runtime? So those are all the constraints that we needed to deal with.
Oh, yeah. So you just mentioned having the existing cars having low memory and having to work with this existing hardware in the cars. So how have you been able to overcome this challenge of limited resources?
Yeah, right. So, to my humble opinion, okay, with after those years of experience with machine learning, with those constraints, I think that the first major thing you can do is to reduce the large data space that you have using
Mm.
physics. Okay? So, if you let sophisticated machine learning algorithms work on the raw data, you'll get nowhere because the search space is big. It means the complexity is huge. It's
Yeah.
a huge data set you need. Everything is huge. So the first thing you need to do is to have abilities like mechanic engineer that design the car, know the physics of the car, and then have a reduction of the entire space into a smaller space, which we call in the industry, we call it features. Okay, so feature engineering, this is the number one challenging when you are driving machine learning out of the real world of the of car of chassis information from the car. So you use those physics, you reduce the set of information or data into those features. And when you have lean features, okay, and condensed features, now even lean resources can work with that.
That's an interesting way to get around that problem. So, yeah, so over time building the business, you've been at this for a while now. What were some of the mistakes you made earlier while building the business, and how did you learn from these mistakes?
So I think that the first mistake, or biggest mistake we did maybe was to aim very high, okay?
Yeah.
Very high with accuracy, very high with availability,
Mm.
very high with the results. And I think that when at the end of the day, we notice that the real world is more complex, it will take more time. You can achieve it, but it will take more time, mainly to collect this data, process it, annotate it, and provide a good machine learning product for that. So sometimes it was too late. So for the product line, for the schedule of the project, etc. So this, I think, was the biggest mistake. If at first we could anticipate those the complexity versus the accuracy that was planned for these projects, I mean, a change of that would be better. We fix it. Okay, so now we're working more gradually with the customers. So we are more, aiming for the moon or aiming for the stars to shoot the moon, but we are more realistic in this world.
No, that's nice. So I understand your major clients are vehicle manufacturers and co. Yeah. So how do you how are you able to work with them? How are you able to get across to them to share the benefits of your products with them?
Right. So we have, I mean, Tactile provides a really novel approach. Okay. We are coming from the data world, the signal processing world, the machine learning world, into a very traditional world of designing vehicles.
Yes.
Okay. Which is, done for tens of years and pretty good, I must say. Okay. Now, if you want to enjoy the machine learning part or the data world or different type of methodology used so far, you need to change your mindset. You need to change of mindset of defining the real problem or defining the product in the vehicle that you would like to get out of those technology, okay? And then you need to modify also the work you do for developing those products, and you need to the way you do for verifying those products. And of course, verification is one of the most important for vehicles for safety, enjoyability, etc. So for the first thing is that not everything can be explained by physics. That's what machine learning is doing. Not everything is explainable. Most of it is explainable, but some is not. And if you are willing to accept it, you can move on with those problems. Second is how you develop. The current way the vehicle industry works is that, let's say that you're developing something in the vehicle, like a steering system or braking system or whatever, okay, and you are like a talented engineer, you will get a small team of 2, 3 people, okay, helping you. You will get 1 or 2 test cars, okay, so you are developing your stuff on those test cars. While those 2 test cars are validated, maybe then there are like a few more testing, like theoretically that it will work everywhere, and then you are done releasing it for production. When we're talking about machine learning, you need to get all the diversions, all those different situations, okay, diversions from the nominal cases. For example, I need to choose different types of tires, different types of conditions of the suspension, of the dampers, okay, of the steering, etc. Climate conditions, of course, tracks, different test tracks, etc., in order to assess that my technology works in order to complete my validation, in order to test it. And this is something that needs to be changed with the customer. So what we do today is that we are collecting information from test fleets, even from commercial fleets, and by doing it, of course, we are enriching our database so we get better results. And then also you need to educate, let's call it, your customers. It's not educating, it's brainstorming together to get to the point is what is the usability of the technology. Okay, so if it's not 100% sure, let's say 99.7% sure, where can you use it? So probably for enhancing performance, other maybe something different. So this is how you work with your customer and taking them from point A to point B, which is working with data rather with car mechanics.
Interesting. So you seem to actually know a lot about your industry. You seem to be really well versed in what you do. So how do you stay updated with the latest in technology in your field? And how important also is continuous learning in your field?
Right. Continuous learning is something that you must always do. And I think that the major challenge here and also the potential is by taking one field, applying it to another field. So being able to learn about machine learning, to be expert about machine learning, but yet deliver it to a world where the resources are lean and the success ratio should be close to 100%. This is the major from real world cases, because if you are doing something first for the first time, you're trying to implement, for example, neural network ECU, then this is something you need to learn a lot how to do it and to bring different expertise to different fields. So talking a lot with people from different disciplines, doing a lot of tests, and never underestimate the amount of data that you need. Always have more data than what you think, because otherwise with machine learning, you can, overfit your solution into one situation or several situations, you will fail the others.
That's really good insight. So what's your vision for the future of tactile mobility and the vehicle industry in general?
So I think that the industry started like 10 years ago with a very motivated and passionate way of doing things to bring the vehicle to level 5 automation. Those days, I think, are behind us. However, this gave us a lot of, urge to accelerate our way of working today. For example, if back then every software platform for the vehicle was fixed for 5 years, okay, like we call it the service pack, okay, then today customers are talking about the software as if it was a release for your smartphone. So every 6 months, let's get a new version of the vehicle. Okay, it's a software-based version, but a new software can provide you or reveal more out of your vehicle. Okay, the same hardware. So instead of evolving every, I don't know, 4 or 5 years, today the industry evolves every half year or 1 year. You get a totally new car, even though it looks the same, but it's a totally new. So this is something that happens. So I think that, there are challenges here. For example, if you modify the software too much or too early, then there are risks of stability, risks of, I don't know, failures, etc. always. However, if you don't do that, you will stay behind your competition. So I think today people in the industry learn how to utilize the power of software changes, but still keep it to the level needed in the automotive industry. So this would drive, this field much further during the next few years. And as for Tactile, I think we were really first, with a lot of aspirations to shoot the moon. We are working towards this direction. Maybe we are now on the Everest or a little bit over that, but this is the direction we go to, slowly but surely advancing our technology and relatively leading the market with those virtual sensors.
Okay, so we've had a really insightful conversation. I've actually learned a lot, and I'm sure a lot of the audience have seen a lot of things. I've seen vehicle technology from an angle which they didn't see it before. So for the listeners who are reaching out to you, probably people with vehicle manufacturing companies or people who are interested in your products or learning more from you or working with you, what's the best way they can reach you?
Right, so reaching us is easy, over the website, tactilemobility.com. So you can approach us. Normally, even LinkedIn, also we have some channels there. We can be seen, in trade shows and other presentations around the world. We are open for meetings, for calls, of course. And since this is a very changing, emerging, fast, all the situations here, so we are open for customers' ID, how to utilize the technology to take it to the next level or to their level. And if I can give, a few tips for the listeners, that have some their own small business or medium-sized business, and they would like, to utilize the power of machine learning or artificial intelligence. Okay, so besides, working with ChatGPT or stuff like this, what can you do? I mean, like inherently for your business. So in order to use some kind of machine learning and other artificial intelligence stuff for your business, I think first you need to identify your data space. What is your data space that you're working with in your business? So think of that like searching within a space of states. Okay, so you can be in any state with your business, okay, according to the data space. And from a state to another, there are transitions. And what we are looking for are the most practical transitions or meaningful transitions to take us, towards a success.
Yeah.
So once you define your data space for your own business and you define your states internally and you define the transitions in between, the next thing is to find the heuristics. Okay, so what should bring me to a better level with my business? How do I score the situations for transition from a state A to a state B? Okay, how do I know that I increase something? Okay, so this is like the score that I give myself, but also penalties. Okay, if I go far away with the search space, then I need to get some penalty. Then after you defined it, you need to define how you get the data. Okay, so you know your data space. How do I get it? How do I annotate it? Okay, this is the major thing. But after you do that, then the rest is almost automatic. And the second tip for that is take an expert. Okay, so find somebody who really knows machine learning or AI, and then he can take you through those questions, okay, with your business and define together those three initial stages. And then from that point on, it's mostly technical.
So for the listeners, you've heard Boaz. try to utilize AI and machine learning in your business apart from ChatGPT, which I know everyone is using already, then that
Right.
means that identifying your data space and defining how you get your data and everything, because like they say in computer, it's garbage in, garbage out. So the data you put in should be the best. And apart from that, if that's a lot for you, like he said, get an expert in AI, in machine learning to implement this for you so that you'll be ahead of other businesses. So thank you so much, Boaz, for sharing with us, for coming on the show today. All right. So, and for the listeners, did you get any value from this episode? If you did, please share with anybody you know. It would help. And if you want to be the first person to know when we post more helpful content like this for your business, don't forget to follow, like, and subscribe to the podcast on whatever platform you're listening to us or watching us on. So we have almost 100 episodes of the podcast. We release an episode every Monday. And if you're listening to this, then you have almost 100 others to listen to till we bring the next episode out. Till next week, or till the next episode you listen to, find ways to keep taking your business, and bye for now.